And we're ready to go. Okay, so what we need to do today is we need to talk about firewall rules. All right, now people will say this is an aspect of security, but it's the kind of an aspect of security that all system and network administrators are responsible for. All right, and understanding a little bit about how the firewall works and going back and reconceptualizing the data flow with the protocol it's important for us to understand. It's a fundamental conceptual thing that we need to have in mind. We need to know how this works. And we're going to just do it in a simple way so that we can see how it works. All right? If you come over to your Windows menu over here, and I don't know where it is exactly. Let me just poke around here in my start menu for a minute. It will possibly be here in Windows Security a little bit. All right, so right here, we have firewall and network protection. All right, and it divides the network into 3 classes so that we can have different security policies for different networks. All right, the close by one, right, private network, or a public network if we're in a coffee shop or something like that. The domain network is the Windows network that is provided by APU here. You probably won't see that, but you probably will see private network or public network. And most likely, if you're around your house, you're on a private network. Now, under firewall and network protection, oh, right. Allow an app, advanced settings. I'm not sure I can get to this, but I just had to run as administrator here. And I should have a window, right, now I got this window up called Windows Defender. All right, and we can make sure that we've got certificates moving back and forth, view and create connection security rules, firewall rules, inbound rules, and outbound rules. All right, if we poke into that, oh, new items to show in this view. Oop, actually there are. It's just taken a while to load them up. All right, and you can see that Windows has all of these rules set up, all right, pre-installed. They're right there for you. Inbound rules, outbound rules, connection security rules, and some settings that we can use to adjust the logging. All right. So this most likely, you already have this running most likely. All right. Oops, sorry, I just gotta fix it. I'm out to readjust. They say at the baseball games. I got a CPU fan problem and thing just slipped. So Windows Defender Firewall is there. You probably have it running, all right? Whether you need it or not, right? Because it's mostly important for machines that are constantly connected to the internet, all right? So what we're going to do today is look at the theory behind this, all right? And then look at our enhancement that relates to writing our firewall rules to secure communications between our TinyNet servers. All right? You can set all that up. We talked about S-tunnel, all right? That's the way to actually secure it on an encryption level, right, up the stack. The firewall rules can allow or deny traffic to move up the stack, right, to get to its destination. We can interrupt that process with our firewall rules and actually just toss it Aha. Thank you for your patience. 10 minutes on and 20 minutes to reconnect. That is the way the network has been here today. So I have no idea what I'm going to do for my next group, but I guess we wait and see. Yeah, it looks the same whether it's connected or not. So it's not a local problem. All right, there we go. Hold on a minute. There we are. Thank you so much. Either that or it is a serious denial of service attack like they had back 6 months ago. There was some real serious problems with the major service providers. But let's take advantage of this while we can. And let's take a look at the theory, right? Network computing people are going to be doing this with Cisco equipment. It's very similar when we do it in Linux, all right? It's actually quite similar to the process that we use for setting it up in the Windows firewall that we took a look at. We've got various groups of input rules and output rules and control the network traffic by watching it as it passes from our network interface through the operating system to get to the process that it's destined for. All right, let's try this. All right, so firewalls and packet filtering, that's the general topic, and as I say, it's pretty much universally applicable. Telnet is the one that we use from the very old style list of services. There's a bunch of these that are called the R utilities because the R is for remote. So this is remote copy, remote distribute, remote sync, get a remote shell, or get a login. All right. And if we secure these over S-Tunnel, they're perfectly useful, right? But we've got a unified replacement for all of this in our SSH clients. But here's the idea. Trust is a substitute for security. This is why, I don't know. This is why some things are so insecure, they're kind of assumed that nobody's really interested in them. And after a while, when people do get interested in it, everybody goes around to try to fix the gaps in security. But this second one, this is a really critical point, all right? More security, equals less convenience. It's a point that we'll come back to. It's a point that's going to be on the final exam because it's so fundamental. All right? It's a concept that we need to just subsume into our minds when we're thinking about securing our networks. All right? But the whole thing starts with a security policy, right? And all network administrators have to take some of this on. It's not solely for the security professionals. We have to look at our system configuration and block obvious potential problems so that we don't have them and get caught in the trap of trying to control the damage when we could have prevented that damage quite easily. So one of the things that we do is this concept of a firewall. And in case you're wondering why it's called that, right, this explanation might not make a lot of sense, but that's why they call it a firewall. It separates the motor and the places where there are little petrol explosions on a very regular basis from the passengers. All right, but for us, we think about a firewall as a single point that examines all the traffic coming in and going out of our network, all right, and making decisions on a packet-by-packet basis, whether this will pass through, all right, or whether it gets tossed away, right? And this point, again, it creates a little conflict of interest for our network architecture because we want to avoid single points of failure. But if we have to channel everything through the firewall, then obviously that becomes the kind of a point that if it's attacked, if it goes down, if there's a hardware failure, the whole network fails. And so it becomes a balancing act of how we want to get this configured, the balance between network quality of service and stability versus security. It's an extension of the idea of more security means less convenience. More security means more complications. All right. Firewalls, again, looking across, I know that people in security will have seen this CIA triangle before and the 3A's security model. All right, just a reminder for them, we're not going to go deeply into those concepts in this class because they're not equally important to everyone. And the people that they are important to should know this already. All right, so this is what we have both in Windows and in our TinyNet, where it is called IP tables, all right? Called IP tables. I don't know why, just the name they invented for it, all right? But it has a history there that is why it's called IP tables. So we're not going to worry about that. Windows, it's called Windows Defender. Windows Firewall underneath Windows Defender. Linux, it's called IP tables. And the kind of more broader picture, like Windows Defender is the broader picture. NetFilter is the broader picture. in Linux, right? So what we're trying to do is put a filter between the public internet and our secured environment. All right? Now, this is a this is a distinction that I think is probably now considered historic. All right, but back in the day, very simple firewalls were strictly packet by packet, but better, more modern firewalls, well, more modern firewalls meaning since the 90s, right, are able to keep a tiny bit of state, right, about the TCP three-way handshake to establish a connection between a client and a server, a TCP connection, all right? And so we'll see that one in action. It's just that this term is one that we need to remember, all right? Even though it is pretty much everywhere these days. It's not like there are firewalls that can't do this in these modern times. Now, this, oh, I got to back up here just for a minute. This network firewall versus a host-based firewall, it's a classic distinction. We have to put it in because everybody still talks this way, but it's just a thing from the 1980s again. And what it means is that an endpoint firewall, when we looked at the Windows Defender firewall, we saw input rules and output rules, all right? On our Linux firewall, we're going to see a third class that's called forwarding rules. And this will apply when we have multiple interfaces in the machine so that it can control the traffic between the subnets. All right? So we could put those kind of rules onto our gateway. And that's what, to the 1980s distinction, makes it a network-based firewall rather than a host-based firewall. Okay, it's that simple. Network-based means it has forwarding rules plus input and output. Host-based means it only uses input and output rules. I don't know why we'll make such a big deal out of that, but there we are. Proxy used to be a huge thing, okay, again, but since the turn of the century, it's not so much anymore unless we're trying to hide our source and destinations. We're trying to play with that traffic somehow, kind of anti-forensics measures to play with the traffic so that it's harder to see exactly where it comes from and where it is going. Even in IP tables, there is a address masquerading function, okay, that can bring in a packet, examine it, and we can write rules so that it substitutes new source and destination IP addresses into that packet before it moves on. That's at layer 2 and layer 3. Proxy, as it shows here, is a layer 4 to layer 7 way of looking at the traffic and making decisions about what it should look like as it goes forward, right? Or if it will go forward at all. And again, proxies used to be a huge, huge thing. They used to be really standard stuff in the late 1990s, early years after the 20th turn of the century. Right? But nowadays, they're not used that much unless we're trying to obscure source and destination IP addresses. Layer 7 firewalls, again, these slightly different than the proxy. I suppose technically we should say that a proxy is working per service, all right? Just like ExonNet can work per service to control traffic based on the time of day, something like that, all right? A layer 7 firewall is one that examines the data part of the packet, all right? It waits until all of the header information is gone. Proxy server still working with the packet header, all right? Layer 7 firewall waits until all the headers are gone and looks at the data portion of the packet. These are getting really common in these modern times, right? Because we need to examine the data, the payload, in order to filter out attempts at cross-site scripting or attacks on HTML attacks, CSS attacks, viruses embedded in documents, malware embedded in images, all right? We need to be looking at the data and scanning it. And our antivirus, not quite the same as a layer 7 firewall, because the antivirus is also working on the applications that we start locally, right? But most now have some of these layer 7 firewall characteristics where they will examine the traffic after it's come across the network to at least set up warnings or to automatically segregate it into a separate space and ask us what to do with it next. You still connected here? Okay, let's see, that's working. Okay, so that's the overview of how we watch the traffic, all right? But all of that relies on some rules, all right? And we think of those rules as being not in a database, but in a list of rules called the access control list. And so for an access control list, the default policy, we have to have one thing or another. So these two basic default policies, you'll see this on the exam review as well. Two basic default policies: deny specific packets and accept everything else, right? Or only accept a few things and deny everything else. So each of these creates different work for the systems administrators, right? So the first one is kind of looser. We allow anything, right, except what we already have studied and decided that we don't want this traffic on our network, right? We make our decisions in advance, and that means we need to keep constantly up to date with what kind of attacks have been happening and how they are working, right? We need to constantly be looking for new types of attacks that might be coming at us. On the other hand, our only other choice is to say, only what I have studied and decided is absolutely necessary can come through the firewall, and everything else denied. Right? This one, you've got to be prepared to keep your help desk staffed and controlled, because your users will be driving you crazy with requests that they can't get through to their favorite social networking site, or they can't get through to their favorite this or that, or they keep losing messages from here or from there, and you're going to be constantly retweaking your firewall rules. And the problem there is, same thing with debugging. Once you change a rule here, unless you've got a very good idea of the flow and the dependencies, you run a real risk of counteracting something that's done somewhere else. All right? Just like fixing one bug in a program creates 2 more bugs in other parts of the program. Right? So there's no escaping the work. It's just the kind of work that we choose to do when we set our default security policy. Now, firewall rule lists, the classic way, the standard way, and the way ours works and the Cisco IOS and such, is that it is top to bottom of the list. Right? It starts at the top. When it finds a rule that matches the packet that it is considering, then it executes whatever actions are specified in that rule, right? And stops processing. Usually, one of those instructions might be to continue back in the list, right? But it depends on the software that we are using, right? Windows Firewall, IP tables, they're pretty limited in the actions that come when a firewall rule is triggered, all right? But there are more sophisticated firewalls that can jump out of the sequential processing of the access control list and jump back into it at another point. Right? In Linux, that's the NetFilter part. Right? That's becoming the standard firewall for Linux. The IP tables was the predecessor, right? But everything in NetFilter is still IP tables compatible because of the huge installed base that grew up over the decades that it was the standard. On most firewalls, at the bottom of the list is implicit deny, all right? In a minute. Implicit deny means accept specific types of packets and deny all else, all right? And that's a policy decision that most people feel is, I don't know, maybe they set it up that way so in case you forget, right, as a default, in case you forget to change it, that's the way it's going to work when you start installing it out of the box. All right, where do we put the firewall? All right. Again, this is an important term to know, this term DMZ, all right? There used to be a few of these around the world based on different kinds of wars and political upheaval. But the only one that we can really point to now was the one set up back in the 1950s that spans the border between North Korea and South Korea. Right? It's some number of kilometers wide where there's an agreement that this space is not going to be used by either of the armies, right? It's the demilitarized zone, and everybody keeps their armies back behind the walls, and this space between them is supposed to keep them from, I don't know, shouting insults at each other or something like that. So that's the term that's been adopted when we have a network architecture where we have a router from our internet service provider. And we don't have much or any of an access control list there. We give all of our internet traffic free access to certain servers. And then those certain servers are, public mail and some file servers, web servers especially, right? Especially web servers that don't have any kind of forms or e-commerce transactions or anything like that, right? Just the public information web servers. We can put those outside the demilitarized zone. And then we put our heavy access control list after those servers, right? I'm going to put up the attendance because I'm sick of this and I'm not going to tolerate it anymore. Let's get this done because this is ridiculous. Good. Let's make sure this gets done and see if we get 10 minutes out of this to get this done. But this is totally out of control. All right. There is a video on Moodle for the IP tables enhancement. All right. And basically what it's about is about writing the rule once and redirecting it into a file. The stuff that we talked about a week or so ago, all right, when we were looking at little tricks for making a shell script and testing our commands and saving them to a file. We'll try to walk through that video. I just don't see how it's going to be possible today, given the state of the infrastructure here. I'm in another class right after this. I don't know how I'm going to do it because I'm not sure I have time to get to some place that has a stable network connection. But this is totally out of control today. And so, ouch, man, never mind. Let's leave it at that for today because I don't want to keep doing this. We've wasted half our time already. And we'll find a way to pick it up later. Okay? So, apologies on behalf of APU ITS, because it's definitely something going on here with the network infrastructure that is not up to the mark. Two of these class things open. Hang on a second. I'm sorry. I'm just disrupting the process there just a little bit. Yeah, that looks like about the case. There we go. There's one more. All right. I'm going to turn this off. We're just going to have to let this go for now because this is ridiculous. And if we get another 10 minutes and another 20 minutes, we've wasted the whole morning. So